Hello and welcome to our lesson on solving systems of linear equations in three variables. This section is going to focus on applied problems, aka word problems. And our main goal in this lesson is to help you see how to translate English to math, how to set up the system of equations from the word problem. And then if you have to work these out by hand, doing it manually, you can refer back to my lesson on solving systems of linear equations in three variables. But for this lesson, in order to solve the system, we're going to be using the calculator. Starting with problem number 3, triangle measures. In a triangle ABC, the measure of angle B is 3 times that of angle A. The measure of angle C is 20 degrees more than that of angle A. Find the measure of each angle. So if it helps you to draw a picture, I highly recommend that you sketch a picture first. I'm simply going to translate English to math, starting with the first statement they give me, where it says B is. Now, the word is in math means equals. 3 times, that means 3 times something. And what are we multiplying 3 times? We're multiplying 3 times angle A. Now, since I don't know what angle A is, I'm simply going to call it A. And so there's our first equation where B is 3 times angle A. Then it says the measure of angle C is 20 degrees more than that of angle A. So our second equation would be C is again is equals 20 degrees more than. Now that means add. So we're going to add 20 to something. What are we adding 20 to? The measure of angle A. And so there's our second equation. Now notice at this point I only have 2 equations, but I have 3 unknowns. In order to solve a system of linear equations, however many variables there are, that's the number of equations needed in order to be able to solve the system. So I need one more equation. And luckily, I know a fact about triangles. I know that if you add all 3 angles together, it must equal 180 degrees. And so there is 3 equations with 3 unknowns. So that's how you set up the problem. And then if you wanted to solve this, I'll go ahead and give you the next step. If you're going to solve manually, what I would do is I would use substitution. Since you have B in terms of A and C in terms of A, then you can substitute for B and C and get an equation in terms of A. So that would be A plus 3A plus A plus 20 equals 180. And then just to finish that off, okay, fine, I'm going to go ahead and finish it off manually. Combine like terms, 3, 4, that's 5A. The 20 moves over and makes it minus 20. So that would be 160. And then if I divide both sides by 5, 160 divided by 5 is, let's see, 5 goes into 16 3 times, remainder of 10, 32. A is 32 degrees. And then if you need to find B and C, it's super easy. All you need to do is plug back into these 2 equations. So angle B would be 3 times 32. And angle C would be 32 plus 20, which is going to be 52. So there's angle C. And angle B, 3 times 32 is going to be 96. And then a quick way to check that. If I add all 3 angles, what does it have to equal? 180. So if I add all 3 of those together and it doesn't make 180 degrees, then I know I screwed something up. So there's manually, which I said I wasn't going to do, but I did it anyway because it wasn't that bad. Now for electronically, if you're going to put this into the Casio, first we have our equation a plus b plus c equals 180. And then the other two equations need to be in standard form. So if I take the first equation and move the b over, that would say 3a minus b. There is no c in that equation. And in that case, that would equal to 0, right? If I move the b over, there would be nothing left on this side, so that would be 0. In the third equation, if I move the c over and then move the 20 back, in order to get that into standard form, that would say a minus c equals negative 20. And so in order to plug this into the Casio, you do have to put those equations in standard form. And notice what I mean by standard form. It says all of the variables lined up, A, B, C, and then on the other side you have the constants. So that's what standard form looks like. Next, once you've got those equations in standard form, in order to input this in the calculator correctly, we're going to go to the menu, scroll down to equation/function option and hit equals. This is a simultaneous or system of equations, and we have 3 variables, 3 unknowns. And then you simply input the coefficients for all 3 equations. So for the first equation, the coefficients are all 1s, and the constant is 180. For the second equation, a and b, that's going to be 3 and negative 1. And then for z, which corresponds to c, we're going to input 0 because there is no c. And then 0 again for the constant. And then for the last equation, a is 1, b doesn't exist, so 0, c is negative 1, and equals to negative 20. Now, if I set these up correctly, if I put it in standard form correctly, I should verify these 3 solutions. I would also like to mention that when you're inputting these numbers into your calculator, if you miss even one sign, it's going to result in instant death, okay? So be very careful when you're plugging these numbers in Casio. Now, let's check. Hitting equals, x, which corresponded to A, 32. Y was B, and Z was C. And so the calculator verifies our handwritten work. And then if you need to go back to the standard mode on the calculator, that's menu and 1. All right, next, number 7, smoothies. Jamba Juice sells veggies, fruit and veggie smoothies in 3 sizes. A 16-ounce, which is designated a 16, a 22-ounce, which is the original, and a 30-ounce, which is power. Okay, so for the 16, since that's the smallest, how about we just use S for small? Original, we could say that's medium, and then power is large. Let's do SML for small, medium, large, and then when we get those values, we will know which one we're talking about. All right, so now we need to come up with equations. Well, let's read on. It says a 16 smoothie sells for $3.90. An original smoothie is for $4.90, and the power is for $5.70. On one hot summer afternoon, that is irrelevant, Elliot sold 34 smoothies. So S, M, and L are going to represent how many of each size were sold. And so there's our first equation. The number of each, if I add them all together, should equal the number of smoothies sold. That's the first equation. It says they sold for a total of $163. So then that's going to be the money equation. How much was a small? $3.90. So if I multiply the price of a small times how many smalls I sold, that'll give me the value I received from small sales. Plus mediums, $4.90, plus the larges were $5.70, and for a total income of $163. So there's the money equation. And then we're going to need the ounces equation. In all, he sold 752 ounces of smoothie. So, how many ounces were in a small? 16 ounces in a small. So, if I multiply the number of ounces a small contains times the number of smalls I sold, that'll give me the amount of ounces sold from small sales. Plus, a medium was 22 ounces, and the large was 30 ounces. And he sold a total of 752 ounces. And so that completes the equation setup. Now, luckily for us, once we translate English to math, you can see that our equations are in standard form. All of the variables are on the left-hand side. All of the variables are lined up. So at this point, we can go straight to the calculator to solve this. And remember, for the Casio, to get to the system solver, you're going to go to Menu, down to Equation/Function, number 1, and there's 3 unknowns. And the coefficients for the first equation are all 1s. The constant is 34. Now, the coefficients for the middle equation are decimals, and that's fine. 3.90, 4.90, 5.70, and 163. And for the last equation, 16, 22, 30, 752. And if I didn't make a mistake, when I hit equals, bam. So how many smalls were sold? 10 small, 16 medium, 8 large. 10 small, 16 medium, 8 large. There's the solution to this particular problem. And if I want to do a quick check, remember, for this to actually check out, it would have to work in all 3 equations. But you can do a quick check to make sure you didn't make some simple mistake by plugging into this easy equation first. So 10 plus 16 plus 8 should equal 34. If it doesn't, you screwed something up badly. All right, next, number 18, student loans. Terrence owes $32,000 in student loans. Poor Terrence. The interest rate on his Perkins loan is 5%. The interest rate on his Stafford loan is 4%. And the rate on his bank loan is 7%. So the first thing I want to do is come up with variables for the Perkins loan, the Stafford loan, and the bank loan. Let's simply call those P, S, and B. Does that make sense? Perkins, Stafford, and bank. If you want to use X, Y, Z, just make sure you clearly label what each one of those variables represents. So we know that Terrence owes $32,000. It says the interest for 1 year totaled $1,500, and the interest for 1 year from the Perkins loan is, that's going to be important, is $220 more than the interest from the bank loan. What is the amount of each loan? Okay, so the first and easiest equation, Perkins plus Stafford plus bank. If I add all three of those up, that should be the total amount he owes, which is $32,000. That's probably the easiest equation to come up with first. Next, let's do the total interest equation. So interest is principal times rate times time. So for the Perkins loan, the principal is, well, we don't know. The rate is 5%. As a decimal, that's 0.05. And it says for 1 year, so the time is 1. So all of these together makes the interest from the Perkins loan. Okay? Plus, now for the Stafford loan, the principal times the rate times the time. That is the interest earned from the Stafford loan. And then for the bank loan, principal times rate times time. That is the interest from the bank loan. And that should equal the total interest for 1 year, which was $1,500. So there is our second equation. It's not simplified, but it is set up, and then we could simplify it pretty easily if we want, which I do want. Okay, so let's simplify that, and we're going to do that in green right above it. That's going to be 0.05p, takes care of that, plus 0.04s plus 0.07b, and that should equal $1,500. So there's our second equation simplified. And so the last thing we need is our third equation, which is going to come from this last statement down here. The Perkins loan is 220 degrees more than the interest from the bank loan. So notice it's referring to interest. So you can't just say P equals B plus 220 because P and B are the amount owed. We're talking about the interest, okay? So the interest from the Perkins loan is 0.05p. That is in math is equals 220 degrees more than, means we're going to add 220 to something. We're going to add 220 to the interest from the bank loan. And the bank interest was 0.07b. And so there's our third equation. There's the interest from the principal equals 220 more than the interest from the bank. And then if you needed to solve that, you can solve manually or electronically. But in order to solve this with the calculator, this last equation is going to need to be put in standard form. And that means we're going to have to move the 0.07b over. That'll give us 0.05p minus 0.07b equals 220. And then if I could, identify the three equations that we're going to put in the calculator. Again, from the Casio, to get to the system solver, that's menu, equation/function, simultaneous, number of unknowns is 3. Coefficients from the first equation are 1, 1, and 1, and 32,000. Second equation, coefficients are 0.05, 0.04, 0.07, 1,500. And for the last equation, now keep in mind x, y, and z correspond to P, S, and B. So the coefficient of P, 0.05. The coefficient of S, well, there is no S, so that's 0. B, look at this, negative 0.07. And the constant 220. And then if I hit equals, we see the amount of money in the Perkins loan, $10,000 borrowed for the Perkins, $18,000 for the Stafford, and $4,000 from the bank loan. Okay, so one more time, now that I've got those written down, the Perkins, which was X, 10,000, Y was the Stafford, 18,000, and Z was the bank, 4,000. And that does it for that example. And for our last example in this lesson, number 21, lens production. When SiteRight's 3 polishing machines, A, B, and C, are all working, 5,700 lenses can be polished in 1 week. So let's go ahead and make a note of that equation. And then what this equation means, it means the number of lenses that A can polish plus the number of lenses that B can polish plus the number of lenses that C can polish. If they're all working together, they can polish a total of 5,700 lenses in a week. Next, when only A and B are working, 3,400 lenses can be polished in 1 week. It's important to notice that the unit of time has to stay the same. So A and B, when A and B only are working, 3,400 lenses can be polished. And when only B and C are working, 4,200 lenses can be polished, again in the same amount of time. So the third equation, B plus C, can produce 4,200 lenses in a week. And this, I must say, this setup was probably the easiest of the 3 or 4 examples that we've done so far. So now that we have this set up, notice it did translate into standard form nicely. You could then solve this manually or electronically. This would be one of the easier versions to solve manually, but we're going to go ahead and solve it electronically. So I've got my ClassWiz ready to go here in the system solver. For the first equation, the coefficients are all ones, and the constant 5,700. In the second equation, A and B, which correspond to X and Y, have coefficients of 1. Z, which is C, we have to put 0 because there is no C. The constant is 3,400. And for the last equation, there is no A. So X is 0, but Y and Z are 1. And the constant is 4,200. So as long as I input all of this correctly and set it up correctly, this should produce the correct answer for how many lenses machine A can polish, how many lenses machine B can polish, and how many lenses machine C can polish. Okay, now that I have that written down, again, X is A, 1,500 lenses. Y is B, 1,900 lenses. Z is C, 2,300 lenses. And again, if you wanted to check that, it would be super easy just to plug back into the first equation and make sure that all 3 of those numbers add up to make 5,700. But to make sure that this is absolutely correct, remember it has to work in all 3 equations. So you should really go ahead and check all 3 of those, especially if this is during a test. And that's going to do it for this particular lesson. So if you have any questions or comments about anything that I've done so far, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.